Good morning, everyone. Welcome to the Print Talk. How are you doing, Kenneth?
Pretty good.
All right, so you're ready to take your 3D printing to the next level, huh? We're diving deep into the world of filaments today, focusing on the big two, PLA and ABS.
Yeah, these are definitely the most popular for a reason, right? We're going to unpack all the little details that really make a difference so you can choose the perfect filament every single time.
Exactly. No more guessing games. No more wondering if you made the right choice. Let's start with a good old-fashioned strength test. If you're printing something that needs to hold up under pressure, like a hook or a clip, which material comes out on top?
A lot of people assume ABS would be the stronger one.
I would have thought so.
But actually PLA, which is often seen as the more eco-friendly option, it's actually got a higher tensile strength.
Really? So we can take more pull-in force before it snaps?
Huh. That is surprising. I guess PLA is always the stronger choice then.
Well, not always. It's not that simple, unfortunately. While PLA might win in a straight tug of war, we also have to think about density.
Right. PLA is denser than ABS, so it packs more material into the same volume. That means a thin PLA hook might be stronger, but an equally thin ABS hook could be lighter and still do the job.
Okay, so it's a balancing act, finding that sweet spot between strength and weight depending on what you're making. Let's change the scenario a little bit. Imagine you drop your freshly printed masterpiece. Oops. Which one is more likely to survive the impact?
That's where ABS really shines. It's got superior impact strength.
So it can take a beating?
Yeah, it absorbs more energy from a sudden shock without cracking or breaking. Now think of it like a foam case that protects your phone from drops.
I see. So it's got that built-in buffer against those clumsiness moments.
Exactly.
All right. Well, speaking of, I once printed a phone stand in PLA, left in my car on a scorching hot day, and let's just say it didn't hold its shape.
Yeah. Heat can be a real challenge for 3D printed objects. The culprit there is the heat deflection temperature.
Oh.
That's the temperature where a material starts to soften and deform under pressure. ABS has a much higher heat deflection temperature compared to PLA.
So my poor phone stand, it just couldn't handle the heat. So how much of a difference are we talking about here?
Well, we're talking about like a 50 degrees Celsius difference.
Wow, that's significant.
PLA starts to soften around 65 degrees Celsius, while ABS can handle temperatures up to 110, 120 degrees Celsius before it starts to lose its shape.
Gotcha. So if you're putting something for outside, or that might be near a heat source, ABS is the way to go.
Yep.
Okay, heat isn't the only thing we need to worry about, right? There's also moisture.
Right, that's another big one. Both PLA and ABS are hygroscopic, meaning they absorb moisture from the air, and that can cause all sorts of printing problems.
Oh no, like what?
Well, you might see poor layer adhesion, which basically means the layers aren't sticking together properly. You could also get little bubbles and stringing on your prints.
Like the silent saboteur of perfect prints.
It really is.
All right, so how do we keep our filament dry and happy?
Storage is key, absolutely key. Keep those filaments in airtight containers. And you can even add desiccant packs to absorb any excess moisture. If you think your filament might have gotten a bit too humid, you can dry it out using a filament dryer or even a food dehydrator.
A little spa treatment for the filament.
Exactly.
Okay, switching gears a bit here. Imagine you want to print a custom cookie cutter. Can you just grab any PLA or ABS and start baking?
Oh, I wouldn't recommend that. While PLA and ABS themselves are considered non-toxic, the filaments we use for printing often contain additives.
Oh.
And those additives aren't always food safe. Plus, there's always the risk of contamination from the printer itself.
Gotcha. So no print and bake situation.
Not quite, but there are specialty filaments that are specifically designed for food contact. They'll usually be labeled as food safe. And make sure your printer is sparkling clean.
Right, to avoid any contamination. Good point. Okay, last question before we move on to the printing process itself. We always hear about PLA being eco-friendly, but how do both of these materials stack up when it comes to recycling and biodegradability?
That's a good question. There are definitely some misconceptions out there. PLA is technically biodegradable, but it needs very specific conditions to break down completely.
So not my backyard compost bin.
Probably not. In a typical backyard compost bin, it could take years, even decades, for PLA to decompose fully.
Oh well. What about ABS?
ABS, unfortunately, is not biodegradable, and both PLA and ABS are technically recyclable, but it's not always that simple.
Right.
So responsible disposal is important, and, seeking out specialized recycling programs is always a good idea.
Okay, so lots to consider there. but we've covered a ton of ground already. Yeah, this is just the beginning. Stay tuned for part 2 of our deep dive where we'll explore the ins and outs of actually printing with PLA and ABS.
All right, so let's dive into what it's actually like to print with these two materials, PLA and ABS.
Yeah, because even though the process is similar for both, there are some key differences we got to keep in mind.
Absolutely, yeah. It's kind of like having two different sets of instructions for baking a cake.
Great.
You're using similar ingredients, similar tools, but those little specific steps and techniques, they can make or break the final result.
I love that analogy. All right, let's talk temperature. Both PLA and ABS are thermoplastics, meaning we got to heat them up to a specific temperature to make them nice and moldable. But those ideal printing temperatures, they're not the same.
That's right.
So we're talking about the hot end here, right? The part of the printer that melts the filament and squirts it out onto the build plate.
Exactly.
Okay, so what kind of temperatures are we working with?
Well, PLA generally likes it a bit cooler, somewhere between 190 and 230 degrees Celsius. While ABS, it prefers things a bit hotter, usually between 230 and 260 degrees Celsius.
Oh, wow. So PLA likes it mild and ABS likes it hot.
Mm-hmm.
What happens if we get the temperature wrong?
Well, if the temperature is too low, the filament might not melt properly, and you could end up with a clogged nozzle or an uneven print. And if it's too high, you risk degrading the filament, producing fumes or even burning it.
Oh, okay. So we got to make sure we get that temperature just right. What about the heated bed? I know that's important too.
Definitely. The heated bed is crucial for preventing warping, especially with ABS.
Okay.
Think about it. You're trying to lay down a smooth layer of melted plastic on a cold surface. It's going to want to curl up at the edges as it cools. A heated bed helps maintain a consistent temperature, keeps those first few layers nice and flat.
I see. So it's like preheating the pan before you make pancakes.
Exactly.
It's everything nice and even. So what temperature range are we talking about for the heated bed?
For PLA, usually around 50 to 60 degrees Celsius is good. But ABS, it's a bit more sensitive, often needs between 100 and 110 degrees Celsius to prevent warping.
So again, PLA easygoing. ABS needs a little more TLC. And I've also heard about the importance of enclosures, especially when printing with ABS. Is this something everyone needs, or other situations where it's more critical?
Enclosures can be a real game changer, especially for that ABS. Remember how we talked about ABS being prone to warping due to rapid cooling? Well, an enclosure helps to create a more stable printing environment. It minimizes those temperature swings that can lead to print failures.
So it's like a little sauna for our ABS prints to relax and solidify properly.
Exactly. It maintains more consistent temperature, reduces the risk of warping, delamination, and cracking between layers.
That makes a lot of sense. What about for PLA? Do we need an enclosure for that?
Usually not. PLA is much more forgiving when it comes to cooling, not as prone to warping as ABS. Unless you're printing in a really drafty or cold environment, you should be good to go without an enclosure for PLA.
Okay, so enclosures optional for PLA, highly recommended for ABS.
Got it.
All right, let's talk about cooling. It seems counterintuitive. We're heating up the filament to melt it, but then we also need to cool it down.
Yeah, it seems that way, but cooling is a vital part of the 3D printing process. Every layer we lay down, it needs to cool and solidify quickly enough to hold its shape and support the layers that come after.
So we're finding that balance between the heat and the cold.
Yeah.
Too much of either, and we mess things up.
Absolutely. And PLA and ABS, of course, they have different cooling needs. PLA can handle quite a bit of cooling, which helps to create those sharp details and crisp edges that it's known for.
So crank at those fans for PLA.
Within reason. Most 3D printers have fans built in, and you can adjust the speed based on what you're printing. For PLA, yeah, you can usually keep them running at a higher speed. But ABS is a bit more sensitive to cooling. Too much of it can cause the layers to cool too quickly, leading to poor adhesion and, you guessed it, more warping.
So finding that Goldilocks zone of cooling for each material is key.
Right.
This is why we dive deep, right? It's those little nuanced details that make all the difference. Okay, so let's say we printed our objects. Everything looks good. Are we done?
Well, we could be. But there's a whole world of post-processing that can really take your 3D prints to the next level.
Oh, I knew it. Post-processing. Smooth out those rough edges, enhancing those details, making everything look super polished.
Exactly. And this is where ABS really has an advantage. Remember, we talked about how it can be smoothed with acetone?
Oh, yeah, the acetone vapor bath. I've seen videos of this. It's like magic. Those rough ABS prints come out looking all smooth and glossy, like injection molded plastic.
Pretty cool, right? The acetone vapor slightly melts the surface of the ABS, erasing those layer lines and giving you that super smooth finish.
So can we do the same thing with PLA?
Unfortunately not. PLA is not as easy to smooth with solvents like acetone. You can try some specialized chemicals and techniques, but it's not as straightforward.
So the acetone vapor bath, that's an ABS exclusive.
Pretty much. But both PLA and ABS can benefit from other post-processing techniques like sanding, priming, painting, even joining parts together using glue or solvents.
Cool. So many possibilities. Suddenly I'm thinking about creating complex assemblies, modifying prints, taking my creations to a whole new level.
That's the beauty of 3D printing. It's all about exploring and discovering new things.
I love it.
But before we wrap up this section, let's talk about safety.
Yes, absolutely. Safety first. Always important when we're working with tools and materials. 3D printing's no different.
Right. Both PLA and ABS are considered safe to work with, but there are some precautions we need to keep in mind.
Like what?
Ventilation is key, especially when printing with ABS. We need to have good ventilation to prevent the buildup of fumes.
PLA, we don't have to worry about that as much.
No, PLA produces minimal fumes and is generally considered safer in that regard. And of course, avoid touching the hot end or the heated bed while the printer is running. Those surfaces get extremely hot.
Right, safety first. Good reminder. Well, we've covered a lot in this part of our deep dive, from temperature settings and enclosures to cooling and post-processing. I feel like I'm leveling up my 3D printing skills already.
That's great to hear.
All right, so we've talked about the science, we've talked about the printing process. Now let's talk about the fun stuff. What can we actually do with PLA and ABS?
Yeah, this is where it gets exciting, right? It all comes down to choosing the right material for the job.
Exactly. So let's start with PLA. It's known for being easy to print with, comes in a ton of colors, and of course, there's that biodegradability factor, which is a big plus for a lot of people.
Definitely. So PLA, it's a great choice when aesthetics and detail are really important. Think decorative items, prototypes, art pieces, those kinds of things. If you need something that looks good and prints reliably, PLA is usually a safe bet.
Gotcha. So it's like the go-to for makers who are all at those visual details.
Exactly.
Okay, but what about when we need something tough, something durable? Where does ABS shine?
ABS really shines when you need something that can handle a bit more wear and tear. We talk about its impact resistance, higher heat tolerance, and how easy it is to smooth and join. So it's perfect for functional parts, mechanical components, enclosures, even outdoor projects.
I see. So it's the workhorse of the 3D printing world.
You got it.
If you're building something that needs to perform, needs to last, ABS is the way to go.
Yep.
But of course, these are just general guidelines, right? Ultimately, we have to consider the specific needs of each project.
Absolutely. Every project's unique.
Now, are there certain brands or types of PLA and ABS that you'd recommend? Some that really stand out from the crowd.
Yeah, for sure. There are definitely some brands that are known for their quality and consistency. The market's always changing, but there are a few that have been around for a while and consistently deliver.
Ooh, I'm all ears.
Very
getting recommendations. It can be so overwhelming trying to choose the right filament sometimes.
Yeah, I get it. So for PLA, some popular choices are Polymaker, Hatchbox, and eSun. They offer a good variety of colors, and the quality is consistently high. Their filaments print smoothly and reliably.
And for ABS?
For ABS, I'd say check out Matter Hackers, Inland, and 3DX Tech. They're known for their high-quality ABS filaments that are super strong and durable.
Awesome. Some great starting points there.
Yeah.
It feels like we've just scratched the surface of this whole world of 3D printing materials. What advice would you give to someone who wants to keep learning, keep experimenting with different filaments?
The best advice, honestly, is just to keep experimenting. Don't be afraid to try new filaments, tweak those printing settings, and play around with different post-processing techniques. That's the beauty of 3D printing. There's always something new to discover.
It's a journey of constant learning. It's what keeps things interesting. Well, we've reached the end of our deep dive into PLA and ABS. Hopefully you feel more confident now about choosing the right material for your next project.
Absolutely. And remember, this is just the beginning. Keep exploring, keep creating, and keep pushing those boundaries.
And who knows, maybe your next 3D printing masterpiece will inspire our next deep dive.
Yeah.
Happy printing, everyone.